Batman voice.
Okay. Average velocity, which uses the what function?
Alternative definition for derivative.
What function?
Average velocity function.
Uses the
Position
function. Remember, I wanted to emphasize that. Even though it says velocity, you're using the position function. So this is s of 4 minus s of 0, because we're 4 seconds, all over 4 minus 0. Which makes sense, right? How far I moved divided by time has passed. So s of 4, help me out, what was s again? It was t squared minus 4t?
plus 3.
Plus 3. Okay, so what is s of 4?
3.
You get 16 minus 16 plus 3, yep. I get 3. What's s of 0?
3.
3 over 4, which gives me
0.
0. Now, units, what am I in? Meters per second. Now, does that mean I didn't move? No, it means I've balanced out, right? Much as I moved in one direction, I moved in the other. Yeah? A lot of us miss this one because they want to use the velocity function here that we're going to do in a minute. Because it says velocity, but average uses the position function.
Will it always be meters per second? Something, distance per
Velocity, yes, exactly. Okay, I want the instantaneous velocity when t equals 4. Now, I didn't have to write instantaneous. I just say find the velocity. This one, you guys will like. Very short.
Doesn't exist.
No.
That'd be really short, though.
Okay. Instantaneous velocity means what?
Take the derivative.
Take the derivative.
Well, yeah.
I don't have to do the limit. I can use my short rules, right? S is t squared minus 4t plus 3. So what is v? Well, it's s prime, right? 2t minus 4. There's my velocity function. I could put v of t, right? Depends on t. But now it says when t equals 4, so I just plug in 4. I get 4 what? Meters per second again. So at 4 seconds. And here's the weird thing. At that moment, I'm moving 4 meters per second. That's kind of mind-blowing. How can I be moving at one moment?
Couldn't you say the same for the seconds 0 through 3 then, since the one above was the same? Couldn't you say they're all 4 meters per second?
Now, say that again.
Well, like, question B said find the average velocity of the particles during the first 4 seconds.
So that,
say the other seconds.
well, that means no matter what I'm doing, if I look at 0, I look at 4, I could be moving all the way in between. But on average, those 2 points, you can line, I didn't really move. Okay, so that's what it's saying is. So that's saying in between 0 and 4, I'm looking at the start and the stop, looking at the difference between the 2. I don't know what's going on in between. However, this one is saying at just that one moment, I'm 4 meters per second. I don't know what's going on before or after, but that one moment. Okay. It's kind of mind-blowing. You think, how can you have a speed at a moment? But that's the idea of calculus is we're looking at secant, taking the limit, until it's pretty much that one moment. And with the acceleration of the particle when t equals 4. What is acceleration? Second derivative. So, if s was t squared minus 4t plus 3, v was 2t minus 4, then a of t is the next derivative, which is 2. 2 what? Do we remember this? The units per acceleration?
2 meters per second squared.
Meters per second squared. Good.
Why'd you say a of t? Oh,
Acceleration. And think about this, it's saying the acceleration is constant. Yeah? Everywhere. No matter what time it is, the acceleration is 2. My rate of change is changing at a rate of 2. It's kind of crazy. My rate of change is changing.
That took that point.
It did.